Good morning. This is Professor Shannon Gracie. We are starting Chapter 3 from the Precalculus with Enhanced Graphing Utilities by Sullivan and Sullivan. And my name is Professor Shannon Gracie, so let's go ahead and get started. Today we'll be learning about linear functions and average rate of change and all that good stuff. So you can read our goals there, and let's get started now with a warm-up. So let's write the equation of the line which passes through the points -3, 2, and 5, 7. So I know you all can do this one. Go ahead and pause the movie and warm it on up. All right, let's see how you did. What do we have to do first? In order to write the equation of the line, you need the awesome slope. So to find the slope, we find the change in y and we divide that by the change in x. So the change in y is 7 minus 2, and the change in x is 5 minus -3. So our slope will be 5 over 8. So now using y minus y1 is the slope times x minus x1, we'll get, I'm just going to use -3, 2. You can use either point. So we'll have y minus 2 is our slope, which was 5/8, times x minus -3. It's really important for you to be able to write the equation of the line for calculus, because what you'll learn is how to do something called differentiate. And when you find the derivative of a function, it's the slope of that graph. So you'll be asked to write the equation of tangent lines. So this is very useful information to know. Okay, so we'll clean it up a little. I'm just going to keep this in point slope form of the line. If you want to get it into slope intercept, you would just isolate y. How'd you do? Very good. Okay, so a linear function is a function of the form f at x is equal to mx plus b. So you were used to y equals mx plus b, so that was written in equation notation. This is written in function notation. So if you can completely isolate y, you can replace that with f at x. So the graph of a linear function is a line with slope m and y-intercept b. Its domain is the set of all real numbers. So let's practice. Graph the linear function f at x equals -2/3 times x minus 4. So go ahead and, oops, sorry. Go ahead and pause the movie and write the equation of this. Go ahead and graph this line. Okay, let's see how you did. I'm just going to use a regular scale. So here, remember that the general form of a linear equation is f at x equals mx plus b. So our m is good, -2/3, and the b is good, -4, because you could write our function that we were given as -2/3 times x plus -4 if you need to do that. So our slope was the coefficient to the x, and our y-intercept was the -4 because there was a plus in the formula. So let's make our graph. So the trick here, you start out by plotting the y-intercept. So that's at 0, -4, right here. And then we're going to use the slope. So you can either go up 2 and to the left 3, or down 2 and to the right 3, since you have a negative. So I'll just go up 2 and to the left 3. I'll do a couple. And then we can go ahead and graph it. turn my screen a little. That's a bad one. That's better. Okay. All righty. Average rate of change of a linear function. Linear functions have a constant average rate of change. The average rate of change of f at x equal to mx plus b is the change in y over the change in x, which is our slope, m. So you already know how to do this. You just have a different name for it. So let's do a little proof about it. So if we start out with the change in y over the change in x is equal to, instead of y2 minus y1, we'll do f at x2 minus f at x1 divided by x2 minus x1. But what is f at x2 and f at x1? They are m x2 plus b minus m x1 plus b all over x2 minus x1. So now, if we take a look at this, we would end up with the b's would zero out. We'd get mx2 minus mx1 over x2 minus x1. And if we go ahead and if we factor out the m, we'll have x2 minus x1 remaining in the numerator divided by x2 minus x1. And these are common factors, so you end up with m. So that is why the change in y over the change in x, which is the average rate of change, is equal to slope. So let's take a look at this example. So determine whether the given function is linear or nonlinear. If it is linear, determine the equation of the line. So we're going to use the property that a linear function, has a constant slope, which means that whatever two sets of ordered pairs you use, you'll get the same slope. So let's just start out with, so we're not working with the fractions. Let's see what happens over here with these two ordered pairs. So do you see that our slope would be equal to 4 minus 2 divided by 2 minus 1. So I did the difference of the y values over the difference of the x values. So that would give me, let's see, 2 over 1, which is 2. Now let's take a look at the slope between these two lines, or these 2 points, excuse me. So we would get 2 minus 1 over 1 minus 0, which is 1 over 1, which is 1. Well, 2 is not equal to 1, so you're done with this particular problem. This is non-linear. Okay, so let's take a look at the next one. So here, let's take a look at these two ordered pairs. So we would have, the slope would be 4 minus 8 divided by negative 2 minus negative 4. That's going to give us negative 4 over negative 2. Is it negative 4 over? Nope, negative 4 over positive 2, which gives us an end result of negative 2. Okay, now we're going to check these points. So our slope would be 0 minus 4 divided by 0 minus negative 2, which would give us negative 4 over positive 2, which is negative 2. Looking good so far. So now the slope here would be -4 minus 0 over 2 minus 0, which again is -2. And lastly, this is looking promising. We have -8 minus -4 over 4 minus 2. That would be -8 plus 4, which is -4 over 2, which again is -2. So you can choose any one of those ordered pairs. Why don't we choose the origin right here, the point 0, 0? So we would have y minus y1 is the slope times x minus x1. Y minus 0 is -2 times x minus 0. So we would get y equals -2 times x. Okay, moving right along. Increasing, decreasing, and constant linear functions. So a linear function, f at x equal to mx plus b, is increasing over its domain if its slope m is, what do you think? Good. If you have a positive slope as you move from left to right, your function is increasing, your y values are increasing. You'll be decreasing if you have a negative slope. And then you'll be constant over the domain if the slope is, good, 0. So if you have a horizontal line, it's a constant linear function. Okay, so determine whether the following linear functions are increasing, decreasing, or constant. So how do we figure that out? We find out what the slope is. So for the first one, I'm going to write it in the form mx plus b. So do you see our slope is the coefficient to the x? So the slope is -4, which is negative. So our answer would be decreasing. Now this guy, if you wrote it in standard form, you could write this as 0 times z minus 6. So again, our slope here is 0, and that means we'll have a constant function. And this guy is already in the format we need, right? So 0.02 is our slope, and that is positive, greater than 0, so it's going to be increasing. All right. So now we've got a graph of a linear function. So let's take a look. So solve g at x equal to -1. So what are we finding? Are we finding a function value, or are we finding an input value? Great, we're finding an input value because we've been told that our y value, our function value, is -1. So what we would do is we would go to where the y value is -1. So this one actually has an ordered pair written out for us, right? And we would put down what the corresponding x value is. So x would be equal to, good, -2. All right, same deal, except now g at x is 0. So if we wrote in this ordered pair here, when the y value is 0, it looks to me like it's at about -3/2, comma 0. So again, we've got this y value of 0, so the x value that corresponds to that is good. It's x equal to -3/2. So this is what we were looking at on these ordered pairs. Okay, so now this is an inequality. So now what we're looking for is when is our, at what input values, so it'll be an interval of input values, do we have our y values, the function values, less than or equal to 3? So you're kind of looking here. If you look here, this here is where y is 3. So you're looking for all of the infinitely many x values that yield outputs that are less than or equal to 3. So do you see that the x value here is 0? So, and then this is an increasing function. So basically all the other x values will be to the left of 0. So on the interval from -infinity to 0, you get y values that are less than or equal to 3. So that is an interval of values for x. Okay, now we're going to solve this guy here, g at x equal to 5. So do you see right here, again, we're back to ordered pairs now. So there is one x value that makes that true. So we would get x is equal to 1. Just a single value, not an interval. All right. Now, again, another inequality. So we want to know when our y values are greater than -1. So now we're looking here. This is where we had a y value. This point is where we had a y value of exactly -1. We want to know all the input values that yield y values that are greater than that. And we don't include this endpoint. So we'll have, it starts when x is -2, but we're not going to include it. So we put a parentheses around there and we go to infinity because it's an increasing function. And now we've got a compound inequality. So we want to know when the y values will fall between 0 and 5. So we have y values. So we're basically looking, on this one, we're basically looking from here to here. So the x values that make that statement true are going to be an interval of values. So and we're not going to include the endpoints. So it's going to go from -3/2 to 1. And again, these are x values. I should highlight. These are both x values. It's an interval of values on x. Interval of values on x. Okay? Awesome. All right. Now we go to our first application. So the monthly cost C in dollars for international calls on a certain cellular phone plan is modeled by the function C at x is 0.38x plus 5, where x is the number of minutes used. What is the cost if you talk on the phone for 50 minutes? So we've been given this function, C at x. So now we're going to be evaluating C at 50 is equal to 0.38 times 50 plus 5. So wherever we see an x, we put in 50 in this particular part. So C at 50 is equal to, we go and get our calculator, So we'd have 0.38 times 50 and then plus 5. Enter. 24. So the cost would be $24. All right. Suppose that your monthly bill is $29.32. How many minutes did you use the phone? So now they've given us information about cost. Well, cost is the output value, the function value. So what we're going to do is we're going to let C at X equal to 29.32, and we need to find out the number of minutes that makes that true. So 29.32 is equal to 0.38 times X plus 5. So if I take away 5 from both sides, I'll get 24.32 is 0.38 times X. And if I divide both sides by 0.38, I'll get the number of minutes. So 24.32 divided by 0.38 equals 64. So 64 is equal to X. So the answer would be 64 minutes. Okay. Now, suppose you budget yourself $60 a month for the phone. What is the maximum number of minutes you can talk? So what we need to do is we need to figure out I hope I didn't lose my pointer here. Hold on one second. So what we need to do is we need to figure out when for what values of X will C at X be less than or equal to 60. So C at X was 0.38 X plus 5, and we want to know when that is less than or equal to 60. So if we take away 5 from both sides, we'll get 0.38X is less than or equal to 55. And then dividing both sides by 0.38, we will get $144.73. But they don't usually, I don't think they usually count partial minutes. So I'm going to round down to the nearest minute so we don't go over our 60 bucks. So we're going to call it 144 in this case. So the maximum number of minutes you can talk is 144. Okay, what is the implied domain of C if there are 30 days in the month? So for 30 days, we have to think about our unit of time, right? We were dealing with minutes, were we not? So basically, we need to figure out how many minutes are in 30 days. So 30 days times, I'm going to do a little figuring before we get to minutes. So how many hours are in a day? 1 day has, good, 24 hours, but we need to get to minutes. So 1 hour has 60 minutes. So if you did it right, all the units will cancel except for minutes, and then you'll have it. So now we just need to do 30 times 24 times 60. So we'll do that, 30 times 24 times 60, enter. So 43,200. So that would be equal to 43,200 minutes are in 30 days. It seems like an awful lot, right? But I guess that's fine. Okay, so the implied domain of C would go from 0 to 43,200 inclusive is the domain for C. Okay, so interpret the slope. All right, so the slope was 0.38 over 1, you can say. So what does that mean? It means for each 38 hundredths of a minute used, you pay an additional $1. And the y-intercept. The y-intercept, it means that an input of 0 yields an output of 5 because of our function was plus 5 at the end. So if you do not use any minutes, you pay $5. Okay, so that is the first application. All right, so the next application deals with equilibrium. So equilibrium deals with supply and demand, right? So in an ideal world, right, your supply will meet the demand. They'll be equal. So the equilibrium price for hot dogs at this game, we would solve that by setting these two linear functions equal to each other. So equilibrium price occurs when supply at price P equals demand at price P. So that would give us negative 2,000 plus 3,000 P is equal to 10,000 minus 1,000 times P. So if I add 1,000 to both sides, I get 4,000 P. And then if I add, or 1,000 P to both sides, I get 4,000 P. And if I add 2,000 to both sides, I get 12,000. So dividing both sides by 4,000, I get P is 3. Okay. So the equilibrium price is $3. Now they also asked us to find the equilibrium quantity. So for this one, let's go ahead and plug in P to the supply. All right, so if I evaluate S at 3, I will get negative 2,000 plus 3,000 times 3, and that's going to give me negative 2,000 plus 9,000, which is 7,000. So the equilibrium quantity is 7,000 hot dogs. By the way, you could have plugged it into either function. They'll get the same. You've equated them so they intersect at the same ordered pair, so you would get the same y value for both. Okay, determine the prices for which quantity demanded is less than quantity supplied. So we would solve this inequality. Quantity demanded is less than quantity supplied. So now we switch them around. So this would be 10,000 minus 1,000 times P is less than negative 2,000 plus 3,000 times P. And if let's see, I'll just keep the P on the left side. So if I subtract 3,000 times P to both sides, I'll get negative 4,000 times P is less than negative 12,000. And then dividing both sides by negative 4,000, you have to flip the inequality. So you would get P is greater than 3. So if you charge more than $3 per hot dog, right, then the demand will decrease, all right? So when the price for each hot dog exceeds $3, the quantity demanded is less than the quantity supplied. Okay, so now this next one. What do you think is going to happen to the price of hot dogs if quantity demanded is less than quantity supplied? So basically, you don't have people buying all the hot dogs. What do you think will happen? Good. The price of each hot dog will drop will decrease. Okay, so that wraps up this lesson. We'll be skipping 3.2 and we'll start up with 3.3 whenever you're ready. All right, have a fabulous day. Bye.